Welcome to this tutorial on the Scikit machine learning tool. In this session, we'll explore a classification task using the AdaBoost classifier. Specifically, we'll be working with the real-world weather dataset to perform a multi-class, multivariable classification. The AdaBoost algorithm builds a strong model by combining multiple weak learners, allowing it to handle complex relations in the data. This weather dataset includes a range of environmental variables. Among numerical features are temperature, humidity, wind speed, precipitation, percentage, and atmospheric pressure. Categorical variables include cloud cover, season, and location, all of which have been coded into numerical form for machine learning. By including both continuous and categorical features, this dataset provides a rich input for classification. Now let's take a detailed look at the dataset. The dataset contains about 13,000 rows and 11 columns. The target variable is weather type, a categorical feature representing different weather classes, such as sunny, rainy, and cloudy. All string columns were converted to integer type using encoding. This pre-processing step ensures compatibility with sklearn's AdaBoost classifier, which expects numerical inputs. In this classification task, we aim to predict the weather type using multiple input features. This is a multi-class classification problem, where the label includes more than two weather categories. This is also multivariable since the feature vector contains several environmental attributes. The goal is to learn the function that accurately maps weather conditions to a predicted class. For classification, we use the AdaBoost classifier, a boosting algorithm that iteratively combines weak learners to form a strong model. Each weak learner is a simple decision stump, and AdaBoost assigns more weight to incorrectly classified samples in each round. This ensemble approach allows the model to handle nonlinear decision boundaries efficiently. We split the dataset into 80% for training and 20% for testing, following standard machine learning practice. After training the AdaBoost classifier, we predicted the weather type for the test set. To evaluate performance, we use F1 score, which balances precision and recall. A higher F1 score indicates stronger model performance, especially when classes are imbalanced. Now let's move to our Scikit machine learning web app to see how to use our web app to implement this task. First, let's name our project here, and then let's give a brief description of our project. Then let's select the data type. Since our data is a CSV file, it's a tabular format. And let's select the attach file. And then let's select our dataset. So after successfully uploading our dataset, we'll have the data information on the right side of our window. So we have the table of all the columns, and if we want to view more columns, we can click next, and then we click the data tab. We have the summaries of our dataset. Now let's select our target label, which is the weather type, and then let's select the machine learning algorithm method. For classification, let's select the AdaBoost classifier. And for evaluation metric, let's select the F1 score. And then let's click perform to see our result. After a few seconds of processing, we can see our F1 weighted score is 0.85, which is really good. A higher F1 weighted score means a higher performance of our model. If we want to see more detailed result, we can scroll down to the bottom of our web app and then scroll to the right, and we can see the two columns, y-test and y-predict. Y-test means the ground truth from our dataset, and y-predict means the predicted value of our dataset. Thanks for watching.